But our question says that a block of mass capital M has a circular cut with a frictionless surface as shown. The block rests on a horizontal frictionless surface of a fixed table. Initially, the right edge of the block is at coordinate x is equal to 0 in a coordinate system which is fixed to the table. A point mass small m is released from rest at topmost point as shown and it slides down. When the mass loses the contact with the block, its position is x and velocity is v. It moves with the velocity v from this point. At that instance, which of the following option is are correct, we have to tell. This is also a multiple choice question. So, in this question, there are two things. One is your conservation of linear momentum. Another is your conservation of energy. Because all the surfaces are frictionless, so there will be no energy dissipation. Let's say this small mass, as we have told that it get detached with a small v velocity, and when the small mass is detached from this capital mass m, it has a velocity capital V. From here, using conservation, what we can say that mv will be equal to capital mv, or we can say that capital V will be equal to minus m by small m by capital M V. Okay. And by conservation of energy, what we can say that it will have energy of half m v square plus half capital M capital V square, and this will be equal to the loss in potential energy of this point mass, which will be equal to mg, and the vertical displacement of small m is capital R. Okay. Now, putting the value of capital V here, we can write it as half m v square plus half capital M, and putting the value v square, it will be small m square capital M square into v square, which will be equal to mgr. Okay. So, now this one capital M gets cancelled out, small m gets cancelled out, and this half if I take on the other side and v square if I take as common, so I will have v square 1 plus small m divided by capital M, that will be equal to 2gr, or I can say that v is equal to 2gr divided by 1 plus small m divided by capital M root. Okay. And which is our option number A. So, A is correct choice. Okay. So, if I talk about capital V, the capital V will be equal to minus small m divided by capital M into small v, which is equal to minus m capital M root of 2gr divided by 1 plus small m by m. And our option D says that velocity of block M is equal to minus m by m root 2gr. So, this should be the velocity. So, this is the wrong option. Okay. Now, let us talk about the displacements. Let us say that this capital block, the bigger block, it moves by a distance of capital X towards left. So, the displacement of a smaller block with respect to the bigger block is R, or we can say that with respect to the ground, the displacement of smaller mass m will be equal to R minus X. Now, all these are internal forces, so displacement of center of mass will be equal to 0, and from here we can say that m into R minus X, okay, that will be equal to m into capital X. Okay. Or we can say that small mr will be equal to mx plus small mx, or we can say that x will be equal to mr divided by m plus capital M. This is in leftward direction. we can put a negative sign here. So as our option B says that x component displacement of center of mass of block M. So we are talking only about block M is minus mr divided by capital M plus small m. So this is again our correct choice. Okay, and the position of point mass x is at the time, let's say this is our x is equal to 0 and it is getting detached from this point. So this distance we have already calculated, and this distance is equal to small m r divided by capital M plus small m. So this will be the position, or this will be the, so this will be the position of the point mass. So in this case the x should be equal to minus m r divided by m plus m and should not be root 2 of this value. So this is again the incorrect choice.